Okay, so those of you who are watching, especially those of you who are doing distance, you can go ahead and take about 3 minutes if you want and try problems 8 and try problems 9. We're now going over these together. It says let f be a differentiable function where f of 2 is 3 and f prime of 2 is equal to -5. Let g be defined by g of x is x times f of x, which of the following is the equation for a line tangent to the graph at the point x is equal to 2. So it's asking for an equation for a line. What two things do you need for an equation for a line? Y equals mx plus b, you need slope and a point on your line, and that will give you y equals mx plus b, correct? So it tells us that we need slope, okay? And by slope, we find a derivative, right? Is it asking for the slope of g, or is it asking for the slope of f? Which one is it asking for? Write the equation for the line tangent to the graph g, okay? So we need to work with g. What is the x value that we're going with? 2. So we start. The x value is 2. Let's figure out the y value. It says that g of x is defined by x times f of x. So in other words, g of 2 is defined by 2 times f of 2. What is f of 2? What's 2 times f of 2? 6. So the point that it passes through is 2, 6. Yes? Now we find the slope. In order to find the slope, I have to determine g prime of x. The derivative of this, that is the product rule. Agreed? What is the derivative of x? 1 times f of x plus x times the derivative of f I could write as f prime. So if you want to find g prime of 2, we would take f of 2. What is f of 2? 3. And we would add that to 2 times f prime of x. F prime of 2 is -5. And so 2 times -5 is -10. -10 plus 3 is -7. So I want an equation that has a slope of -7 and passes through the point 2, 6. Slope of -7 is only one of these, and that would be letter D right there. Looks like a tricky problem. Once you see it work through, really not too bad, is it? The instantaneous rate of change of x equals 2. This has one purpose, okay? One purpose, that you understand instantaneous rate of change simply means derivative. That's what instantaneous rate of change means. The derivative. The slope at 1 point, instantaneous, not 2 points, average. So, if I want to find the derivative of f, what rule would I need to use? Quotient. Derivative of the top is 2x times the bottom, x minus 1. Minus the derivative of the bottom is 1 times the top, x squared minus 2. I divide that by the bottom squared. Whoop. X minus 1, quantity squared. What do I plug in for x? 2. 2 times 2 is 4. 2 minus 1 is 1. 2 squared is 4, minus 2 is 2. Divided by 2 minus 1 is 1, squared is 1. So I have 4 minus 2 is 2. 2 divided by 1 is dos, which is Spanish for 2. There you have it. Let's try another kind of problem. Implicit differentiation. Suppose we have x squared plus y squared is equal to 9. We would like to determine y prime. As I determine y prime, I first have to find the derivative of x squared plus y squared. Implicit differentiation, what's the derivative of x squared? 2x plus derivative of y squared, 2y, y prime is equal to derivative of 9 is 0. So I subtract the 2x and I get 2y, y prime is equal to negative 2x. I then divide by 2y. I get y prime is equal to negative x over y. Good? Let's try one more. Suppose you had this equation. 2xy is equal to sine of x plus y. In order to find the derivative of 2xy, I need to use the product rule. Derivative of 2x is 2 times y plus 2x times, how do I write the derivative of y? Y prime equals sine of x. What's the derivative of sine of x? Very good, positive cosine. And the derivative of y is y prime. Uh-oh, I have two y primes. How do I begin solving for y prime? Gather everything to one side and factor it out. So you have 2xy prime minus y prime is equal to cosine of x minus 2y.
Wait, so you got 2y plus 2x.
I did the product rule, yep. And so we factor out the y prime, leaving with 2x minus 1 is equal to cosine of x minus 2y. So y prime is cosine of x minus 2y over 2x minus 1. That is my derivative. Implicit differentiation will come up. I know that you guys may have forgotten some of these pieces. Think of this like a final exam for the end of the year. That's normally what you would have in college, right? Be cumulative, probably worth 50% of your grade. And similarly, that's what we're doing. We're just taking a lot of time to review for it. Okay? Problem number 10, problem number 11. Take about 3 minutes. See what you come up with. Ready, set, go. So let's see what chance we have with these. Slope of the line tangent, so I need to find this derivative. Fortunately, I know how to do that. The derivative of 3y squared is going to be 6y prime. Minus, and the derivative of 2x squared is 4x. Equals, the derivative of 6 is 0, minus, and then I have to take the derivative of 2xy. The derivative of 2xy requires the use of the product rule. Very good. Derivative of 2x is 2 times y plus, and then I have 2x times the derivative of y, which is y prime. So notice what I have here. If I distribute, I get 6y, y prime, minus 4x is equal to negative 2y minus 2x, y prime. So it's saying, what is the slope at the coordinate 3, 2? So I want to find y prime given the point 3, 2. Some people at this point are solving for y prime. You don't have to. You can plug in 3, 2 and see what you come up with. Watch. If y is 2, then I get 12y prime. If x is 3, I get 12. If y is 2, then I have minus 4. And if x is 3, I get 6y prime. So now if you gather them, you have 18y prime is equal to, add the 12 over, you get 8. Divide by 18, you get 8 over 18, which in other words is 4/9. See a few people had that one correct. Good job. This one's a little bit more gettable. This is one you want to see this on the test. You want to say, yes, I know I can do this one. We are going to set up with, as Blake said earlier, the chain rule. He was just a step ahead of us. Good job, Blake. Sine of u and xy. The derivative sine is cosine of u, and the derivative of xy is 1y plus xy prime. So therefore, the derivative of sine of xy is y plus xy prime times the cosine of xy is equal to the derivative of x, which is 1. So now we're solving for that. In order to solve for that, I need to distribute the cosine. So I would have y cosine of xy plus xy prime cosine of xy is equal to 1. I'll have to subtract the y cosine of xy to get xy prime cosine of xy equals 1 minus y cosine of xy. Then I'm going to divide off the x cosine of xy. And at this point, you maybe stop because you see that the answer is sitting right there. It is, in fact, letter D as you divide off that x cosine of xy. What about related rates of change? I don't know if we really remember anything about related rates of change. I'm getting a definite no, I don't remember anything about related rates of change there. So what if we said that you had area was equal to pi r squared, and you wanted to take the derivative with respect to time? So related rates meant that everything changes with respect to time. And when you took the derivative with respect to time, remember we said you came up with a prime is equal to 2 pi r prime. Do you remember setting up that little dealie? Okay. So using that, see if you can spend just 2 minutes. Look at this one, and I think you got a shot at doing this. It tells you the surface area of a sphere is 4 pi r squared. Ready, set, go. Let's see what we got. It says the radius of a sphere is decreasing at a rate of 2 centimeters per second. At the instant when the radius of the sphere is 3 centimeters, what is the rate of change in square centimeters per second of the surface area? So surface area is equal to 4 pi r squared. So what I'd like to do is take the derivative. That means that the surface area prime is equal to 8 pi r prime. So it's asking what is this rate when at the instant when the radius is 3, so this radius is 3, and the radius of the sphere is decreasing at 2, so that means this has a value of negative 2 as it's decreasing. So if we multiply these together, we should get a negative 48 pi. What's that? I promise that you are going to get better. Trust me. Okay. Right now is that kind of that rush of all the things we've covered. You'll be like, I can't believe I forgot all this. Because I hope you look at that probably just did and you said, yeah, we did that one. Or how about this one? A person whose height is 6 feet is walking away from a street lamp that is 15 feet tall, and he's walking away at a rate of 4 feet per second. The question is, at what rate is the distance of his shadow changing? Does that problem look familiar? It should. So instead of you just staring at it, do you remember the setup for this kind of a problem? Somebody, please. Yeah, so we don't know this distance here, but we do know that this is the length of his shadow. We'll write that as S. So I'm going to simply just write a ratio, the height divided by the shadow. So 6 divided by S is equal to the height of the lamppost, 15 over D plus S. Now, in order to make this look nicer so that we don't have like the quotient rule or something like that, let's just cross multiply to get 6D plus 6S is equal to 15S. And as we gather our S's, we see that we have 6D is equal to 9S. And finally, if we divide by 6, we get D is equal to 3 halves S. So that's the ratio. The distance is always 3/2 of the length of the shadow. That's always the case. But this problem involves distance prime and s prime. So let's take the derivative. The derivative of d is d prime. The derivative of s is s prime. At what rate is his distance changing? What does the problem tell me? Walking at a rate of 4 feet per second. That's how fast that distance is changing. So 4 is equal to 3/2 s prime. Do we know how to solve for that? Multiply both sides by 2/3, and we get 8/3, or 2.667 feet per second. What does the mean value theorem say? They will ask questions on the mean value theorem. Yeah, that average rate of change. And what the mean value theorem literally says is this. I'll draw the picture to make it as plain as I possibly can. But it says, suppose that you have a coordinate here, and suppose you have a coordinate there. If the function is continuous and differentiable, which is a fancy way of saying it behaves nicely. It doesn't have any corners. It doesn't have any gaps. It behaves nicely. So if you have a function that is differentiable and continuous, what it means is that if you consider the average rate of change over that interval, there's a spot on that interval where if you take the derivative, you get the same as that average rate of change. So can somebody tell me when to stop my pen? You're going to tell me to stop my pen where at the spot where if you were to draw a tangent line, it would look parallel to this red line. Somebody think they can do that? You tell me when. Well, that was what happened? Sure. Now, there's another one that we talk about. It's kind of a corollary to this one, and it's called Rolle's theorem, and it says this. It says, suppose that there's two spots where the function travels through the x-axis. And we'll say that the function is continuous and differentiable. It says that if it passes through 0, so what's the average rate of change from 0 to 0? Does it increase at all? So the average rate of change is 0. It says that there has to be a spot where the derivative is 0. So those are kind of the two ideas. Let's look at one that's more complicated. We'll look at one that's easier. It says the function f is continuous for those values. Continuous from -2 to +2. Does it say it's always differentiable? It does not say it's always differentiable. So it could have a corner, couldn't it? It says f of -2 equals f of 2, which equals 0. What does that mean? What does that mean? What is f? Go ahead. Yeah. So exactly. So a lot of times it will give you that, and people will they'll just right away they'll space out. Right? I can't do it. Yeah, you can. If you plug in -2, you get 0. And if you plug in +2, you get 0. So I'll draw a couple examples that would work for that. I'll draw one in red. Function might look like that. Function might look like that. Is it possible for the function to look like the green one? Why? Because it says it is it says it is continuous, and the green one is discontinuous. So the green is not an option. Look at what it says. It says there's no value c. There's no spot where the derivative is equal to 0. Is there a spot for the red where the derivative is 0? Yeah. Is there a spot for the black where the derivative is 0? No, there's not. So it's probably something more like the black one. And it says, which of the following statements is true? Does the derivative always have to be greater than 0? As you look at the black? No. Is the derivative always less than 0? No. Does the derivative always exist for the black one? Can you take the derivative everywhere for that black one? No. The derivative exists, but it's not continuous. No, that can't be either, because it says it's continuous, doesn't it? Let's look at the last one. For some value k, f prime of k does not exist. That's the one. The derivative does not exist. We've actually looked at a couple values like this one before. You can go ahead and talk together on it. Take 2 minutes. See where you can come up with this problem number 15. Good luck. Okay. What does this mean right here? F prime of 3 equals 2. What does that mean? That means the slope. Yeah. And so we want to find a table where the slope would be a total of 2. You tell me, what's the increase in the y values from here to here? To get from 2.5 to 6.5, what's the increase in the y's? 4. What's the increase in the x's? 2. So if you go 4 over 2, what do you get? 2. So this is a candidate. Okay. What's the increase here to get from 2.5 to 7? 4.5. So that would not give me 2, would it? So this is not a candidate. Increase to get from here to here? So this is not a candidate. 3 to 7? That's an increase of 4, right? Divided by 2 would be 2. So this is a candidate. And then this one, 3.5 to 7.5 is an increase of 4 divided by 2 is again 4. So those two are candidates. So see how the average rate of change is 2 for all of those over that interval? That means that that satisfies a mean value theorem. Now we have to look at the second piece, which means the second derivative is less than 0. So that means the increase is becoming less each time. 2.5 to 5, what's the change there? 2.5. And then 5 to 6.5, the change is? So is the change increasing or decreasing as you go from here to here? Decreasing. So this is another candidate. Let's look at this one right here. 3 to 5 and then 5 to 7. Is there any change there? They're the same. So this one is not a candidate. And then 3.5 to 5, that's a change of 1.5. And this is a change of 2.5. That's not a candidate because it's going up. So A is the correct result. Okay, we'll have time to look at this one last piece here. Increasing for functions means f prime is greater than 0. If the first derivative is greater than 0, then it's increasing. If f prime is less than 0, it is decreasing. You remember this, if you have a local maximum, f prime changes from positive to negative. And if there's a local min, f prime changes from negative to positive. Concave up means that the second derivative is greater than 0. Concave down means the second derivative is less than 0. And the point of inflection means that f double prime changes from positive to negative, or f double prime changes from negative to positive. That was chapter 4. You did really well on that test because you were really smart. Those are the pieces. That is the quickness. Flip it over. And we have a little bit of time. 1, 2. How many do we have? Do the first 3. Do the first 3. Ready, set, go. Okay, let's check this last grouping out together. The graph of f prime is shown for f. On which intervals is f increasing? F is increasing wherever it's above the x-axis. So from negative 2 to 1, and then from 1 to 3. So negative 2 to 3 would be your answer right there. Number 17. This is the first derivative. I've graphed the first derivative. The question is, where is it increasing? Well, wherever it's sitting above the x-axis, which is from 1 to 1.69. I used my operation of second calculate 0 to find that spot. And then for the final one, the graph of the derivative is shown. The graph has horizontal tangents at -1, +1, and 3. Which of the following does f have a relative maximum? That's where f prime changes from positive to negative. Where does it change from positive to negative? So you were looking at f prime. You're treating it as though you're looking at f. If this was the graph of f, it would have a maximum there and there. You're looking for f prime changes from positive to negative. It is at the value of 4. This is the graph of f prime, correct? So where does f prime change from positive to negative? Here's above the x-axis, it's positive. Here's below the x-axis, it is negative. Hey, good work. Tough stuff. You'll get better. I promise.